Good morning to one and all. My name is C. Sohit and I am from ECD section, roll number 4J8. Today my topic is about torque slip characteristics of three-phase induction motor. What is an induction motor? An induction motor, also known as an asynchronous motor, is a commonly used AC electric motor. In an induction motor, the electric current in the rotor need to be produced torque is obtained via electromagnetic induction from the rotating magnetic field of the stator winding. The rotor of an induction motor can be a squirrel cage rotor or wound type rotor. We'll be knowing about the rotor and the types of rotors later. How does an induction motor work? It is simple. From the name itself, we can understand that here the induction process is involved. When we give the supply of the stator winding, a magnetic flux gets produced in the stator due to the flow of current in the coil. The rotor winding is so arranged that each coil becomes short-circuited. The flux from the stator cuts the short-circuited coil in the rotor. Working of an induction motor. As the rotor coils are short-circuited, according to Faraday's electromagnetic induction, the current will start flowing through the coil of the rotor. When the current through the rotor coils flows, another flux gets generated in the rotor. Now there are two fluxes. One is stator flux and another is rotor flux. The rotor flux will be lagging with respect to the stator flux. Because of that, the rotor will feel a torque which will make the rotor to rotate in the direction of the rotating magnetic field. This is the working principle of both single and three-phase induction motors. There are two types of induction motors. The types of induction motors can be classified depending on whether they are a single-phase or a three-phase induction motor. The types of induction motors are single-phase induction motor and the three-phase induction motor. In this video, we will be discussing about the torque slip characteristics of the three-phase induction motor. The torque slip curve for an induction motor uses the information about the variation of torque with the slip. Slip is defined as the ratio of difference of synchronous speed in the actual rotor speed to the synchronous speed of the machine. Variation of slip can be obtained with the variation of speed. That is, when speed varies, the slip will also vary, and the torque corresponding to that speed will also vary. Now, this is a curve of a three-phase induction motor, where you can see that this graph is in three regions: braking region, motoring region, and generating region. The torque slip characteristics curve can be divided roughly into three regions. Those are low slip region, medium slip region, and high slip region. Characteristics. The curve can be described in three modes of operation: motoring mode, generating mode, and braking mode. Motoring mode. In this mode of operation, supply is given to the stator sides and the motor always rotates below the synchronous speed. The induction motor torque varies from 0 to full load torque as the slip varies. The slip varies from 0 to 1. It is 0 at no load and 1 at standstill. From the curve, it is seen that the torque is directly proportional to the slip. That is, more is the slip, more will be the torque produced and vice versa. The linear relationship simplifies the calculation of motor parameter to great extent. Now generating mode. In this mode of operation, induction motor runs above the synchronous speed and it should be driven by a prime mover. The stator winding is connected to a three-phase supply in which it supplies electrical energy. Actually, in this case, the torque and the slip both are negative. So the motor receives mechanical energy and delivers electrical energy. Induction motor is not much used as generator because it requires reactive power for its operation. That is, reactive power should be supplied from outside, and if it runs below the synchronous speed by any means, it consumes electrical energy rather than giving it at the output. So, as far as possible, induction generators are generally avoided. Finally, the braking mode. In the braking mode, the two leads are polarity of the supply voltage is changed so that the motor starts to rotate in the reverse direction, and as a result, the motor stops. This method of braking is known as plugging. This method is used when it is required to stop the motor within a very short period of time. The kinetic energy stored in the revolving load is dissipated as heat. Also, motor is still receiving power from the stator, which is also dissipated as heat. So as a result, which motor develops enormous heat energy, for the stator is disconnected from the supply before motor enters the braking mode. Thank you.